Welcome to part 3. In this part, we're going to take a look at the FXML controller file for the standard desktop project. Here's the controller. It is complete. It is what powers the original desktop standard that we looked at in the very first screencast when we actually ran the program. Let's take a look at what's happening here inside of this class. It begins, of course, with our traditional logger. Remember, professionals log, amateurs do system.out.println. Next, we have two references to two objects that are going to be required. One is the DAO object, and the second is the fish data bean object. Neither of these will be created in this FishFX table controller. Instead, they will be created in the main app. This allows us to share these references with other parts of the program should that be necessary. The next group of variables all begin with @FXML. This tells us that these are the result of the Scene Builder FXML file. Each of these, as variables, are never instantiated. Nowhere will you see something like resource bundles, resources equals new resource bundle, or new table view. Instead, the JavaFX framework will take the responsibility for creating these objects and then injecting their references into these variables. The annotation @FXML is how JavaFX knows what to do and where to do it. These are all the items we gave FX IDs to. Resource bundle is where the internationalization comes from. Once we're finished with all the individual variables, well, we do have a constructor. I pointed out that the constructor is not particularly useful. However, since the controller is not generated with a new, but rather generated through a factory method, we cannot have anything but a non-default controller, and that limits its usefulness. Next is the initialize method. We saw this generated by Scene Builder, though the generated version we saw were full of assert statements to determine whether or not a particular component was properly created. I've removed those. It may be a best practice to leave them in, but for our purposes, we don't want to clutter our initialize. What initialize is doing, though, is it is making the association between each column and the appropriate property that's necessary to retrieve data from our beans. So we see each of the FXML names, set cell factory, and then a lambda which associates a method that will retrieve the value and display it. This is how our table connects with the data. Adjust column widths. We'll see that method later on. As I pointed out, we're going to control the column widths programmatically. Next, we have a listener, specifically for what's called a selection change. When you click on a row, a pop-up appears that shows you all the fields in that particular record. This is the code here that sets up a listener. There's my listener based on what I select in the selection model. Remember, model is another word for bean. It is a data structure in the table that keeps track of where you've pointed to. What is the current row? And when that selection happens, we are going to call the method here showFishDetails. Here's our first FXML method. If you remember, we had handle close. It receives a reference to type action event, where we can get information about the event. We're not using it here, but it's available to us. And since close means to end the program, we use the JavaFX platform.exit. We do not want to use system.exit. Platform.exit is the JavaFX way of ending a program. We saw the fish data and fish DAO at the beginning of the file. Because these objects are created outside of the controller, we need a set method so that this information can be passed in here. Oops, I noticed an error. I see the fish data, or the fish DAO, but I've neglected to put in the fish data. So let's do that now. Fish data equals fish data. Good, that's in place. Next, display the table. Once everything is set up, once our table is created, it's ready to be displayed, we need to fill it with records. That's the responsibility of fishdataTable.setItems. It requires an observable list of FX objects. These FX objects have fields whose names match the properties that we saw earlier on. Let's slide up here. Here are the property names: common name property, Latin property, PH property. All of these are names from our bean. So now we can say we want to display the table, and we're providing the table with the items for it to display. Any type of query in our DAO that returns 0 or more records can be used to set items in our table. Next, I have adjust column widths. Each of the widths is a percentage of the total width of this particular stage. I have, in this example, hard-coded a width to ensure that everything would fit properly. Ideally, I should calculate the width. I should also be responsive, but for this first example, we're keeping it simple and we're working with calculated values. I retrieve the preferred width. This is the width that at the moment the table has been set to. I believe it's 1500 pixels wide. Then, using that total width, I assign a percentage of it. So you see numbers 0.05, 15. In other words, 5%, 15%, 15% of this width to each of the individual columns. These are the column names from the FXML. And I call upon set preferred width. This will be the width of each of the columns. Remember, there's a pop-up box that appears when you select a row in the table. Well, that's what's happening here. I create an object of type alert dialog. Alert dialog allows me to set the particular icon. Some icons are used to represent errors. In this case, this is an informative dialog. Next is the modal setting. Dialog boxes can be modal or non-modal. What it comes down to is, do you wish to have the dialog take control of the screen, prevent the user from doing anything else until they usually click OK or cancel in the dialog? Or do you want the dialog to pop up, but you can leave it on the screen and continue to work in your object? A non-modal dialog, and that's what I've set for this example, if we look at the comments, it says it does not block. whereas a modal dialog has to be released before any further work can be done. The alert class gives us methods that allow us to display information in the dialog. We have another dialog at the very end that's responsible for the About box. It's responsible for displaying information about the application and what its purpose is. Well, that pretty much takes care of everything in this controller. It's simple, but it does demonstrate all the main aspects of any given controller.